Good morning. Welcome back to the last few days here before winter break. I'm having you watch a video today because unfortunately I am not available today. I have an appointment I have to attend to. So I want to still give you an opportunity to understand what we're doing today and also give you your deadlines for this week. So today, Monday, December 21st, you will not have a Google Meet per se as an entire class. The expectation is to watch the video. Obviously here on the PowerPoint, there's not a video link provided yet because I'm creating it right now. Today, what you need to do is follow along in the video that will discuss Welder Math Unit 17, four-sided measurement. I will walk you through that and expectations. And then I'm going to walk you through Blueprint Reading Unit 16, tolerances, which deal with fractional and angular. Now, because it is a very short week, as you see down here on your screen, both of the homework assignments are due by 11:59 p.m. tonight. Tomorrow will be a quiz review day, as we see here. So tomorrow we will have our Google Meet link. And then looking at Wednesday, this is where you're taking your quizzes. So again, it is a very fast turnaround to complete your homework assignments today, tonight. And again, if they're not completed, unfortunately, you will receive no credit in the grade book. So again, we're going to walk you through these two, and please make sure they are done by 11:59 p.m. tonight. So we're going to talk about the math unit first. Your math unit is going to be four-sided measurement, which realistically is basic geometry. Now, we're not talking proofs and theorems if you've already taken geometry before. We're looking at a couple key things here. We're looking at basic geometry for a square, a trapezoid, a parallelogram, and a rectangle, focusing only on two ways to determine sizes. One being area, which for most will be a length times a width, and a perimeter, taking care of all the sides of that particular shape. So here's the catch. The formulas are provided in this packet that you see on the screen. Please use this packet as your formulas for the quiz on Wednesday, as well as please use the formulas to complete your homework tonight by 11:59 p.m. So they're first going to talk about a square, showing you what the perimeter of a square is going to be. So a square, you add up all four sides, not just the two you see dimensioned. So now we have to do a little bit of blueprint reading also to do some of the math. Then they're going to have you work on area of a square. Area of a square is multiply the two sides. So length times width, width times height, whatever it's going to be. Then they're going to move on to a rectangle. Same thing here. Perimeter of a rectangle and area of a rectangle is identical to a square. Perimeter being add up all four sides, as well as length times width for your rectangle. The parallelogram now is going to change things a little bit. Perimeter is going to be the same, thankfully. So again, it's repeat. We're adding up all four sides. Okay, again, a parallelogram, your two opposing sides are equal length. So you'd have 193 top and bottom and 64 left and right. The area of the parallelogram, is going to be a little bit different. Now we're taking the length times the height. So now this is where you want to definitely use this packet to make sure you have the correct formula. Okay? So area now for parallelogram is the length, the longest side, times the height. And then finally we're moving into the trapezoid, which is down here. And again, perimeter of a trapezoid is add up all the sides, adding up all four sides. So thankfully, perimeter is a repeat for all four shapes. Add up all four sides for the square, rectangle, parallelogram, and the trapezoid. However, the trapezoid area is going to be a little bit more labor intensive. So I strongly recommend that you write your work down on a piece of paper to keep track. And here are the steps shown here in the packet to calculate the area of a trapezoid. So you're going to add your two parallel lengths. So in this example, 331 plus 262. That number is a 593. Then take that total of your two parallel lengths and multiply by the height. So here we have our height of 204 millimeters. Take that answer and divide it by 2. So this is the step you're going to do for the area of a trapezoid. And again, use this packet, use the PDF packet for your formulas. And obviously this packet will be made available for you when you take the quiz on Wednesday. For that math assignment, there are 15 questions, as you see here. Now, some of these are also going to ask you to do some conversions. Well, the conversions are also listed in that packet. So dig through that packet, find the conversion chart, and then it has you start to move on to area. It has you move on to perimeter. Area of an L-shaped part. Perimeter of the parallelogram. Area of the parallelogram. Perimeter of the trapezoid, and area of the trapezoid, and so on. So there's your 15 questions for tonight. All of the conversion charts and all of the formulas that you need for these different shapes are in that PDF packet that I just showed you. Again, this assignment is due tonight by 11:59 p.m. Moving on to the blueprint. Now this is our second to last blueprint unit. So once we return from winter break, we have one more blueprint unit to complete, and then your workload starts to drop off. So now what we're working on here is tolerances, fractional and angular dimensions. Well, guess what? Based on our math units, we've already worked on tolerances where we have plus or minus. Sometimes it's only going to be the minus, and conversely, sometimes it's only going to be the plus dimension. So this is going to be review for you. So they have here your plus or minus 64th as example. And you will see here a note on most blueprints that will say tolerances on a traditional fractional dimension are plus or minus a certain dimension. It could be a fractional, it could be a decimal, and in this application it's going to be angular as well. And as you see here, they talk about your upper limits, which would be your maximum size, and your lower limits, smallest size, would be your minimums. So again, this is going to be a review for you. Here is your angular dimensions. Well, in our most recent math, doing angular measurement, now we're able to do the math unit first, and then immediately follow up with the angular dimensions the week after. So this is also fresh in your memory. So we have our degrees, our minutes, and our seconds. We've talked about reducing. We've shown you how to convert and reduce these down. Now, I'm not going to have you convert these to decimal degrees. There's just no purpose for our application right now. Yet you should be able to figure out your tolerances. So in figure -1, they give us a tolerance of plus or minus 0.5 degrees, meaning it's a half a degree. So if we're at 45 degrees, half a degree is going to be 30 minutes. So we can't say 44.5. We have to be very particular and do our conversion to minutes. So at plus or minus half a degree, we'd be 45 degrees, 30 minutes. Our lower limit or our minimum size would be 45 degrees, 44 degrees, 30 minutes. They also have here too a tolerance where it could just be plus or minus 10 minutes. I don't believe they're going to do seconds because you're getting very, very minute and very small sizes. But this gives you an idea of how to use this. So what you're doing here, and I'm going to pull up the blueprint as I scroll through the old work, is this is going to be the part called the sector pattern. Blueprint number 16. It is made out of wood. Order number, part number, I need 2 total. Your fractional dimensions are going to be plus or minus a 64th, and your angular dimensions are only going to be plus 5 minutes. Because it's only plus 5 minutes, that minimum number that you see, let's say it's 45 degrees on your blueprint, the smallest size, the lower limit, is still going to be 45 degrees. The maximum, or your upper limit, with a plus 5 minutes for your tolerance, would make it 45 degrees, 5 minutes. That's it. So we're not going to do any subtracting of your angular dimensions. There's nothing to subtract because it's 0. It washes itself out. So this now too is where you're probably going to need to use a calculator to help determine at least the fractional. So on this blueprint here, we have our front view, we have our top view, and here's your three-dimensional cutaway part. So they're going to ask you to determine what is size B, what type of line is E, or what does it represent. 60 degrees is the only angular measurement found on the blueprint. They're going to ask you what type of line is D, figure out size G, what type of line is A, what does C represent, what is F for a size. And again, we have some radiuses. We have a counterbore with a depth of 1 inch with a diameter of 9/16. The 1/4 inch here is the part that's shot the whole shot all the way through. So a lot of this is going to be review because we've already talked about the counterbore. We've talked about the depth symbol. We've walked you through how to determine sizes, calculate sizes, identify line types, and in a mathematical sense, we've already done the tolerance work. So everything from here on out now is going to be completely review for you. This blueprint assignment is going to be a total of 10 questions. So as I scroll through here, they're going to ask you about what's a hidden edge, what's a dimension line, extension line, figure out size G, what's the diameter of the pilot hole drilled for the counterbore, what's the diameter of the counterbore, so on and so forth. So this is going to be review for you because we've done this type of work previously. To wrap up here, again, you have that homework assignment for math and blueprint due tonight by 11:59 p.m. I already have it labeled in Parent Portal, so you can see now that you also have due dates as of today when I'm creating this video. Tomorrow, we will do a very simple quiz review looking at your work. And then Wednesday, we're going to run that like a normal Friday. It's the end of the work week. It's our last day of the week. So your Google Meet will be optional. But again, we're only working on the quizzes. And notice there is no OSHA 10. So we're just focusing on the math, the blueprint. We'll wrap up the math. We'll finish the blueprint next time we're together after winter break. And then we have a couple weeks of OSHA 10. And then we move on to the end of unit semester final. In OSHA 10, summative final test, welder math, summative final test, and blueprint reading, summative final test. So, enjoy the rest of your day. Please get the homework done tonight. The homework is due tonight. And if you have any questions, please send me an email. I will be checking email later this afternoon after my appointment to answer any and all questions. If not, we will see you tomorrow morning for your quiz reviews. Have a good rest of your day. We will see you next time.